see there. I was just looking at this flower and I was thinking about how it's entirely made of atoms. You know what? I don't even know what an atom is. But we'll find out. In the past, scientists thought that the atom looked somewhat like this, some sort of a ball. But now, modern scientists have concluded that the atom looks more like this. I'm here with my assistant Kari, and she's holding a model of an atom. In this model, there are three components: electrons, protons, and neutrons. The protons and neutrons make up what's called the nucleus, and the electrons fly around the nucleus in an electron cloud. Each of these components has a different charge. As I said before, each component has their own charge. The proton has a positive charge. You can remember that because they both start with P. And then we have the neutron. This one has no charge. And then we have the one surrounding proton and neutron. It's the electron. The electron is negative.
Oh no! So many neutrons all over the counter.
Don't worry, I got a sham Chaswick.
What's a sham Chaswick?
Sham Chaswick is this great material developed by Mr. Chaswick himself.
Oh my gosh.
Neutrons.
As I said before, protons are positive. When you have two protons, one, two, they're both positive. And when they come together, just as two positives repel each other, two negatives will also repel each other. When you have two opposite charges, a positive and a negative, they attract. Look, they're inseparable.
Have you been involved in an accident caused by scaring and driving? Call the law offices of Rutherford and Proton. Rutherford and Proton are the leading law office dealing with scaring and driving accidents. They also have a history of conducting experiments dealing with gold foil. Due to these experiments, they have discovered the proton.
Atoms have an overall charge. It can be either positive or negative. What causes a positive or negative charge is if there's an excess of one type of charge. If there's an excess of positive charges, then the overall atom is going to be positive. But if there's an excess of negative charges, then there's going to be a negative charge for the atom. That made me tired. I'm probably going to go to bed now. Yeah. Hold on. I just remembered I gotta talk about charges. How charges really work, you know? Kari, get over here! God.
Sorry.
My assistant Kari. She's gonna show us how polarization works. We're gonna take this charged piece of plastic from a 5-star notebook and put it on Kari's uncharged hair. Notice what happens. It's charged now. Thank you, Kari, for that wonderful demonstration. Now I'm going to show you charging by induction. Let's say my hands are one charged object and one uncharged object. When I bring them close together, the charged particles from the charged object are going to shoot to the uncharged object without touching.
Hello everyone and welcome to this edition of Physics Trivia. I'm your host, Kimmy Fellers. I am here with our two lovely contestants this evening. Tell me, what's your name and what school you go to?
I am Kari Harbison and I go to Carmel High School.
I am Cathlina Cooper, and I also go to Carmel High School.
Okay, great. Well, welcome, ladies. Let's go ahead and get started. First question. Who is the lawyer who specializes in the scaring and driving accidents and discovered the proton? Yes, Carly.
Was it Ernest Rutherford?
Correct. 1 point for you. Okay, next question. What charge does a proton have?
That would be a positive charge.
That is correct as well. Okay, final round, ladies. Whoever gets this one wins our prize tonight. The question is, who discovered the electron and how? Carly.
Was it J.J. Thomson through the cathode ray experiment?
That is correct, Carly. Congratulations, you are the winner of a GMC Denali. Woo!
Oh my god!
Thanks for... Well, that wraps up our show tonight. Thank you, everybody, for joining us on this edition of Physics Trivia. I'm your host, Kimmy Fellers. Good night.
All this talk about charges has really got me fixed on electricity. And you probably know that electricity flows through wires and stuff, and those wires are similar to this metal coat hanger. See, charges would pass through this metal all the way to the end at the speed of light, and this metal coat hanger is what's referred to as a conductor. As well, on the other hand, you have the entirely opposite thing, an insulator. This is an example of an insulator. It's a shoelace. Now, if you tried to pass any current through this, nothing would happen. It would simply stay. My assistants and I, thank you for joining us on this edition of the Mr. Professor. Join us again at Monday night at 6 p.m.